Having this one is that if we have the limit as x goes to a of f of x equaling L, then the limit as x goes to a of c times f of x is equal to c times L. Now, to do this, we want to remember the definition of a limit, and we want to see what it is that we need. So in this case, right, we want to show that for all epsilon, we want to show for all epsilon greater than 0, there always exists some delta. I could always find some delta greater than 0 such that the following is true. So if I show this, that I could, for any epsilon greater than 0, I know that I could find some delta greater than 0 such that for all the x in here, if x is in here, if x is within delta of a, this will immediately imply that c times f of x is within epsilon of c times L. And if I show this, if I could find something that makes this true, if I could find a delta, or if for any epsilon I can find a delta where all the x in here will make this one true, then I'm done. And I can do that because I have this fact here. So if you look at this here, right, what you have here is you have that by this being true, you know that for all epsilon, and in particular, you know that for all epsilon divided by c, so this is the same epsilon divided by the absolute value of c, is greater than 0. I know by the definition of a limit in this one that for any number greater than 0, including the epsilon that I talked about here, this was any epsilon. Now, the absolute value of c, let's say c is not 0. The result is trivial when c is 0. We'll talk about that at the end. But let's imagine c is some non-zero value. Then, right, this is some epsilon. Epsilon divided by the absolute value of c is still greater than 0. So this at the end of the day is just some other epsilon, right? And I know that by the definition of a limit that I could find some delta. And that's exactly the delta that I want. This delta that I would need in order to make this statement true. So the statement here would be that x minus a, as long as I choose an x within epsilon divided by absolute value of c, okay, then as long as this delta, as long as I choose, this is going to be a delta here. So if I choose an x within delta of a, then I know that this function value will be within epsilon divided by absolute value of c. Sorry about that. It will be within epsilon absolute value of c. And if we look at this, what you can do is you can sort of manipulate this. So you could say that this will immediately imply, if I multiply by the absolute value of c, right, on both sides, I get this. And I get that this function will be less than epsilon. And multiplying by the absolute value of c will keep this inequality true. And then this one essentially implies that the absolute value of f of x times c minus L times c is less than epsilon. And that's exactly what we have up here. So I found a delta that will make this less than epsilon. So this, I found the delta. The delta is the delta that I would use for this limit here to make this so it's less than epsilon over absolute value of c. Now, we're not quite done. We just need to state one last thing if c is 0. If c is 0, then you get the limit as x goes to a of 0. And it doesn't matter what you're tending towards. The limit of a constant is always the constant. And once you have this, you're done. You've shown this immediately implies this statement that the limit, once you have this, right, this goes to here, you have it. This means that the limit of c times f of x as x goes to a is equal to c times L.